Hello. I'm going to guide you through network marketing. It's not network marketing. It uses the binary system of network marketing, but inputs it as a false impression. The false impression is the builder. It's kind of like an interactive game, but it's not a game. It's holographic because it encodes multiple data at the same time, and it is built by nodes, clusters, edges, hypergraphs. But that was the beginning. What's really new is the hypergraphs turn into networks. The edges turn into scribbles, but the scribbles, that's what I call them. They're actually the network. But the way you go through the easier pattern is writing it as scribbles or a dollar sign. Let's just call it a dollar sign because that's the exchange. That's the nominative system, and because that encases that, it changes it to a hierarchical, non-hierarchical logic. And after that, it encodes a different system, and it is linear, but also non-linear. So the way I'm going to do this is go on my message board, find a person called Saul, give him 0, 1, 2 permucoins, and if he gets 0, 1, 2 permucoins, that goes into the system, and it cycles. But it doesn't even have to be 0, 1, 2 permucoins. That's the thing. That's just the truncated verse. So if that works that way, then essentially it's kind of like I give him whatever. Like I can say it's TSUB plus minus 2 number sign squared, and it's just random nominative. And then what happens here is I create a structural algebraic differential expansion modular over all these summation that creates a fractal system, and that fractal system is capable of encoding a higher length hierarchical data that lets you draw as if you're writing on a canvas that is textually computive, and it's like a computive data. And let's say this computive data works like a keyboard, but you go through the keyboard and you tap it. You tap the buttons, and it's basically like a keyboard. But every time you type a button, it gives you a list to write out. So, but the list is going to be what you write out. So I got STUFDX 1, 2, 3, 2BC, and that's to be continued. But 2BC adds like a structure to it. It's almost as if you're embedding your thoughts and your experiences onto the data right here. But if, let's say, we say Saul purchases 012 coins, what happens is that his money will double 200%. But not just 200%. It has all the stats. the stats take measure. So if it's 200%, then it's 720 degrees and 2 tau, 2 pi, and because we're doing this accurately, we name the radius 1, the denominator 2, and the other aspects, the trigonometry structure. If it's 200%, then a trigonometrical function for sine, is it sine times sine plus cosine, or sine times cosine, or sine divided by cosine, but it reveals that it's 2. But it's not because it's sine in cosine, it's 2 sine, 2 cosine, 2 tan, 2 ctc, 2 cot, and it goes to that. And these are just the aspects of the system, but each of it is embedded in like a hyperlattice of nodes, and each of the nodes affect each other by the differential equation system. And the differential equation system creates modular carryover. So you can make a word called move, and above O create A, above M create N, above N create O, down M create S, T, at. And this sounds like move, but it is encoding the system in the letter. We're encoding the system in the word and in the letter, thus creating a structure that if he bought 012 Permicoins, then he actually is embedding the 0, the 1, and the 2 all together with the functions of 0 divided by 1, 1 divided by 2, 2 divided by 0, and the occurrence of transient across collective. So if that creates that function, then you basically have a carryover expansive numeric system that is basically like fractive, metafractive, whole number system. But we don't have to use it like that. We can just focus on the nodes. So here's the cool thing about the node system. Because it's truncated as a false pyramid scheme, the pyramid scheme is not the business. Because the pyramid scheme makes no money. You make no money in the pyramid scheme. It is the code. The pyramid scheme is the code. So what you're really using is the nodes. Let's say I have 4 nodes. In one node, I have 4 more nodes. In this second node, I have 4 more nodes. In this third node, I have 4 more nodes. In this fourth node, I have 4 more nodes. And in each of those smaller nodes, it's nested inside 4 more nodes, 4 more nodes. And that creates a self-descriptive algorithm. We could say 1 node equals 4. And the 4 is the lattice node system, which is a graph. But the graph is related not to X and Y, but the nodes are the ratio of ratio builder, which is this to that, and it creates that system because it is a ratio. 4 to 1 is a ratio because it occurs everywhere. So that means if you follow the system accurately, before the original 4 nodes were there was a 1. So if 1 node equals 4, then 1 node equals 4 node equals 1 node, and it goes on forever like that extensively. But we're going to the next page. Here, I'll show you what I created so far. It's a system. It's pretty crazy. It's complicated. But we're trying to figure out how this system works. So essentially, you have a system of glyphs. You create a glyph on paper. Let's say it's a random scribble. That scribble is explained by the next scribble. And because you have two scribbles, you can do anything you want with those two scribbles. Because you have those two scribbles, you can make it 6 times different effects. Six times. How? It's kind of strange how it works. But it's like a... It's hard to say. It has to relate to pi. Oh, I know how to do this. Pi to the first times... Oh no, pi times 1 times pi to the first over pi times 1 times pi to the first, and it creates a truncated system like that. And that is an embedded hierarchical system that is basically a lattice. And that lattice creates a recursive fractal system. But because we have these two glyphs, we can create a glyph that explains a second glyph. And the cool thing about this is it's not adding to go to the next one. You explain each glyph to the next glyph, and each one will be original. The more you run out, the more you realize that you'll have to figure out how to convey the system accurately. And the only way you do this is truncate by adding a cut. You cut the original glyph and create a sprout. That sprout grows and it encodes the data like going through the graph system. The data is the graph system. You truncate another one, another glyph, you go through that graph system, and then you're able to run through how it all works. So, how does it work? Imagine you have a square and you move it into 4 positions. The square goes 1, 2, 3, 4. But because there's another, it goes back to the original one and it repeats. That is a permutation. So, that's the original, right? But here's the thing. If you have the original right here, it goes 1, 2, 3, 4, 5, 6. The outside is going to be different. It's going to be 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It goes 12 times. So that system goes 12 times. And if that system does go 12 times, then essentially it is the square. If it has 4, the higher permutation would be the outer stretch of the square, which would be 1, 2, 3, 4, 5, 6, 7, 8. It goes 8. And then it goes further. And there is a way to do this to make it go further. All you have to do is embed another square lattice on top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think 1, 2, 3, 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 16. So it goes 1, because it's originally 1 square. 2, 4, 8, 16. And it repeats like that. And later on, when you have 2 squares aligned with each other with their 4, then you have a double. Then you're able to convey a whole 8 bout system conveyed with 2 letters that goes to a higher dimensional value just with a square. So you have a higher dimensional set point for a square, and if you increase it to 3 squares, it's more. But to make it even harder, each square can be sprouted like scattered. And to build it, you need to move through dynamic. This is cool. You don't realize how cool this is, but it's a dynamic ladder through multiversal set point in algorithm through stock market spirals and inflation through the scale. It goes up, down, scalar, steady, up, down, scalar, steady. But the cool thing about this is that every step of the way, you have nodes. You have nodes embedded in this market cap stock market portfolio. So we have the stock market portfolio, and we have how the stock market was running. You embed nodes in that territory, essentially changing that structure into a graph. You can do this with anything. This is the important thing about business in fake multi-level marketing. You can exchange intuitional sense. If you want to exchange with Diego, you give him chips. In turn, you get a feedback loop, which is impressioned as infatuation that you just gave something to him. That's a feedback loop. It leads you to the structure, and you don't have to go through that emotional spiral all the time. You can go through a cycle of it. A whole embedded cycle body, and you can not think so hard to go through that process. So later, you can go through that process with little effort. But it's boring. I have to tell you, it's really, really boring. This is the thing. This is a whole boring course. We need to make this exciting. And the way to make this exciting is to add distinctions. Distinctions are like electricity, like qualities. Kind of like in mythology where you have fire, water, earth, air, like magic. But instead, we don't need to use that. We can use objects like let's say a mouse, a computer, desktop, internet, YouTube. I'm going to watch a video called Kingdom Hearts 3 footage. What's happening in the footage? Well, you're going to embed a node system to find out what's exactly going on in the footage, and then your brain automatically knows how it works. Then we won't really need to use the internet all the time or go on video games all the time. We can basically have somebody in the audience on a stage doing a fight. We get our controllers out and we match the interactive style. We're playing the game interactively because we remember how the process of feedback works. We're essentially playing real life. How do you know you're not controlling the person across the room? How do you know they're not controlling you? When you distinctly understand the controller versus you, you don't know if the simulation is just running tests on each other. Are we controlling each other? Or is it different? This is the important part. This is not meant to scare you, because that's what old systems try to do. The important distinction is that fake multi-level marketing is like a scare tactic. And I use it importantly as a scare tactic. Because it's fake. It's a fake scare. It's fake horror. Fake adventure. It's a hierarchical, non-hierarchical set point. It's non-cumulative data points that act as official. That's why I'm King Andrew. King Andrew acts as a fake until we make it real. And if we make it real, then it creates a structural imbalance. But we need more balance to that. This whole hyperlattice system can connect. But the cool thing about this is if we create the structure of the fake MLM correctly, we can use the, let's say, next page. Hey, let's say we have a node and another node and another node, and we have an edge. We have a node, and an edge. That node creates an edge. That node creates further double node, triple node, quadruple node, edge, and it collects all of that. This whole system can be embedded with the solid logician scribble system. So you can embed a glyph that you already created, but it doesn't have to look the same. But it will be remembered as what you had before, because no matter what you're remembering, your memory doesn't work the way you want it to. You can embed the glyphs in the system, and the way the system works is that whole formula is going to create a message through this whole system of what to do next. And this whole system runs like a cooperative group. That's all I have to say for now.